All right, guys, here we go again. This is a really good assignment. Maybe I should have made this the official review because there's a lot of good work on here. If you want to do excellent job on this quiz, you're really taking this seriously and trying your best. So this first section here, this is exactly like what the quiz asks. This is the first scenario on the quiz. I'm telling you that right now. We got this right triangle over here. We do need the missing side. So we're going to do some Pythagorean theorem before we even start the question. You do have calculators, so you could just type in the original numbers into the calculator. They're not that bad, but I'm going to go ahead and do it by hand the way we've been doing it. Divide by 2 would be 6. Divide by 2 would be 5. So it's going to be the square root of 6 squared minus 5 squared. That's 36 minus 25. So this is the square root of 11. And since we divided by 2 to get there, we're going to multiply by 2 to go back home over here. So now we have all three sides of the triangle, and we're going to do all of these. Now, angle B is a right angle. We are not going to do trigonometry on a right angle. That is not for today, that's for sure. So let's go through. We're going to go really fast. Actually, let me explain this. When I say what is the sine of A, that means I want the sine ratio for A. So, toa. I want the sine ratio, which is opposite over adjacent. So if I go to angle A, the opposite side is 10, and the opposite over hypotenuse, and the hypotenuse is 12. So the sine of A equals 10 over 12, which is 5 over 6. That's the answer I'm looking for. Do not type in inverse sine of 5 over 6. Do not tell me that's a 56-degree angle. Don't do that. I did not say how big is the angle. On the quiz, if I say A equals, now you better tell me how big the angle is. So this is a big deal. Sine of A is just what is the sine ratio for angle A. Cosine of A, same thing. It's going to be 2 root 11 over 12. So 2 root 11 over 12 reduces to root 11 over 6. Now, actually, it would be easier to use this triangle because they're already reduced. But you do have to have fully simplified answers, my friends. Sine of angle C, same idea. That's going to be 2 root 11 over 12. Our perspective is now angle C, so things switch up. When I'm looking at angle C, now this is opposite and this is hypotenuse. Well, we just said that reduces to root 11 over 6. Cosine of angle C is 10 over 12, which reduces to 5 over 6. And then finally, tangent. These will be the hardest ones. The tangent of angle A is the hardest one here. Tangent of angle A would be opposite over adjacent for angle A. 10 over 2 root 11, which reduces to 5 over root 11. But we can't leave the root 11 in the denominator. You will have a calculator, so you could just type it in, but you do need to have it fully simplified or you won't get full credit. Tangent of angle C is a little bit easier. It's opposite 2 root 11 over adjacent 10, which reduces to root 11 over 5, and that one's already done. So first section of the quiz looks just like this. Make sure that you understand the difference between finding angle A and finding the sine of A, etc., etc. Here, this exact question is on the quiz as well. There's two things going on here that I'm trying to figure out. Do you know how to round, and do you know what an angle is and what a ratio is? Let's try to be as clear as possible. Let's go back to toa. The first part is the sine of theta equals opposite over hypotenuse. In this scenario, theta is the angle. Opposite over hypotenuse is the ratio. For example, on number 1, when I say the sine of 55 equals, and I type that in, and you do just type it in, the sine of 55 equals 0.8192, 0.8192. In this scenario, this is theta, this is opposite over hypotenuse, this is the angle, and this is the ratio. So when I say round angles to the nearest degree, am I going to round this to the nearest degree? No, that's not an angle. And ratios to the nearest 10,000ths, I have to know what it's referencing. This is the angle, This is the ratio. So that's 0.8192. That's the nearest 10 thousandths. Over here, when I write this out, tangent of B, this is the angle, this is the ratio. I have the ratio, I want the angle. So what do? I'm going to do the work up here. I'm only going to do this on this one, but if I write this out, tangent of B equals 18.2522, how do I solve for angle B? How do I get the angle? Well, I do inverse tangent of both sides. And what that does is it cancels out the tangent. And then I have inverse tangent of, type this in, inverse tangent of 18.2522. And I get 86 point, oh, it's round to the nearest degree. Round angles to the nearest degree. So it's going to be 87 degrees when I round it. So B equals 87 degrees on that one. Inverse tangent of the ratio gave me the angle. So if you have a ratio, you're doing an inverse. All right, we're going to go a little faster. Inverse cosine of the ratio. So I'm going to type this in. A is going to be the inverse cosine of 0.2215. Well, what is the inverse cosine of 0.2215? I get round to the nearest degree, I get 77 degrees. I'll go ahead and do the tangent one down here. This is the angle. I'm looking for a ratio this time. So when I type in tangent of 22, this is just tangent 22. Just type it in. I round to the nearest 10 thousandths. That'd be 4040. You got to have that placeholder 0 if you're going to the nearest 10 thousandths. Over here, tan of 82, I'm just typing it in. So I type in, oh, hit the wrong button. So I type in tan of 82, and I round to the nearest 10 thousandths. That's 7.1154. Got to round correctly. This is a ratio. I have to round that to the nearest 10 thousandths. And finally, here I'm going to do inverse cosine. So J will equal the inverse cosine of 0.5151. And I type that in, inverse cosine, 0.5151. And I get 59 degrees when I round to the nearest degree. 59 degrees. Those exact questions on the quiz. It's really, do you understand the question and how to round? It is not hard to type that stuff in. Some follow-up questions to this. Since sine of theta equals opposite over hypotenuse, theta equals opposite over hypotenuse, and hypotenuse is always greater than opposite, can opposite over hypotenuse ever be more than 1? Well, if the hypotenuse is the bigger number, won't that always be less than 1? I want you to think about that. Food for thought. Moving on. What is angle of elevation and depression? Really, really quick reminder. You must have a horizontal line. Elevation is the angle above the horizontal line. Depression is the angle below the horizontal line. Also, if I have an angle of depression from one object to another, that angle of depression is going to be equal to the angle of elevation for the other object. So if this is 50 degrees, then this will be 50 degrees. Those are alternate interior angles. They are equal. These won't necessarily be equal because they're going to different places. But if it's between the same two objects, depression and elevation will be equal. Mark every angle of elevation with an E and every angle of depression with a D. Well, this has an elevation and an elevation. You don't actually have to mark that one, but technically that is an angle of elevation. This doesn't have any. It's going down. I know it's going down. Same thing over here. That is not depression. Sorry, I forgot to bring that up. Look at those two sides. Are either sides horizontal? No. If there's no horizontal line, there's no depression. No horizontal line, there's no depression. You've got to have horizontal lines to have depression. There's an angle of depression. Technically, that's an angle of depression, right? Isn't that an angle of 90 degrees angle of depression? Yes. Over here, angle of elevation going above a horizontal line. Angle of elevation going above a horizontal line. Angle of elevation above a horizontal line, and elevation again above the horizontal line. Depression and depression, got it. So you have to have horizontal lines to have elevation or depression. Do not call this an angle of elevation. That is just an angle facing up. That's a totally different thing. Okay, we're going to do quick work here, right? Quick work. Okay, I'll do one slow, but overall quick work. I need you to know how to do these. So if you're watching the video and you need help, let's make sure we can do these. This is what we call basic trig. Basic doesn't mean easy, but it means there's not a lot of complexity. They're about to get harder. So we got to make sure we can do these. Every one of these questions, first, SOHCAHTOA is the key to it all. If you don't know your formulas by heart, write it down. Pick an angle. Decide how the other two sides relate to the angle. So 12 degrees, x is opposite, 10's adjacent. We got OA, so we go to SOHCAHTOA. Hey man, I got that OA, what you got for me? Well, it's got a nice tan. So the tangent of theta is opposite over adjacent. Okay, on your quiz, you don't have to write all that out. What I'm writing in blue is what I would expect to see. I need to see the setup. Tangent of the angle equals opposite over adjacent. If x is up high, all you got to do is multiply. So I need to see what I'm writing in blue. I need to see the setup. I need to see the work. I didn't give rounding instructions. Let's go to the nearest thousandths. 10 times the tangent of 12 to the nearest thousandths would be 2.126. And that is how long, and that makes sense because if that's 12, then this is going to be 78. And 78's a lot bigger than 12, so it makes sense that our side's a lot smaller than 10. So I'm not going to do slow like that every time, but that's the process I'm thinking through. I'm thinking cosine of theta equals adjacent over hypotenuse. Cosine of theta equals adjacent over hypotenuse. If x is down low, x and the other side switch places, you know. Right? I showed you how that worked in the other video. Go watch it if you need to. 18 over the cosine of 21. We're rounding to the nearest thousandths. We're practicing that. That would be 19.281. Quick check. That's a hypotenuse. Is it bigger than 18? Yes. If that's 21, then this would be 69, which makes sense. 69 is a lot closer to 90 than 21. Makes sense that those numbers are kind of close. Okay, again, I'm thinking through this. I have adjacent hypotenuse. The cosine of theta, 18, equals adjacent over hypotenuse. If x is up high, all you got to do is multiply. Get it right your first try. So 32 cosine 18. I'm going to round to the nearest thousandths. That would be 30.434. All right, we got one more here. I'm thinking through my formulas. This is opposite over hypotenuse. So the sine of theta equals opposite over hypotenuse. I know the ratio this time, so to solve for the angle, you need to do the inverse of sine to cancel out the sine. So inverse of sine of one side means I have to do the inverse sine of both sides. So we have inverse sine, shift sign in your calculator of 13 over 15. Please practice typing this in. And if I'm going to the nearest thousandths, that'd be 60.074. All right, good stuff. Let's crank it up. This is a much harder question. Let's see what we can do. We got 3 right triangles. Do you see them all? There's only one right triangle I can work on right now. I wish I could work on this one, but I can't. I'm going to draw this one off to the side just so we have it, but let's think about it. We have a right angle, we have x, we have y, and we have 15. To work on a triangle, you need to know, well, first you do need the right angle, but then you need one side and one angle. I need a side length and I need an angle. Well, I have a side length, but I don't have another angle. All right, the blue triangle over here has a 12 and a 90, and that's it. So can I work on this triangle? No, there's not enough information there. And then finally, I'll make it a little thicker. Maybe we can see it a little better. The big triangle, I'm going to make it green. we do have enough to work on the big triangle. The big triangle is a right triangle already with a 12 and a 15. So can I work on this triangle? Yes. What would be most helpful? Well, is this a side of blue or pink? No, that side's not helpful. I could get it with Pythagorean theorem, but not helpful. This angle would be on the blue triangle, but while that's helpful, I could get stuff if I knew that. It doesn't help me get x and y. We're trying to get x and y. So this angle, the bottom right angle, is the angle I'm going to get. I'm going to call it W because they've already used x and y. Once I know W, I can put it right here. And once I know this angle, I can solve for x and y. So that's the process here. So W would be opposite over adjacent. So this would be the tangent of W equals opposite over adjacent. From there, I'm going to do, sorry, I just got distracted. So from there, I'm going to solve for W. That's an inverse tangent of 12 over 15. I am not going to type that in. I am not going to round that. That is just my number. That is what I'm going to just write. That's going to go right here. I don't need to type that in and round it. We don't want to use rounded numbers. That's not what we're doing here. And then that's also going to go right here. This is the angle. Just leave it like that. Nice and clean. Don't give me rounded numbers. Now we have enough to solve for x and y. So I'm going to do it in two parts. First, let's solve for x. That's the first one that's a little bit easier. X is going, well, what do we know about these two angles? They're going to add up to 90. So I know x is going to equal 90 minus inverse tangent 12 over 15. And I'm just going to, now I'm going to type it in because this is the thing we're actually looking for. Once you get to the objective, which is x, now you can type it in and round it. But don't use rounded numbers to get new answers. That's not good math. 90 minus inverse tangent 12 over 15. I'm going to keep going to the nearest thousandths, probably most of this. And that's going to be 340. So there's my x. Got it. Then I'm going to get y. So let's work on y. Y is a side length. This would be adjacent hypotenuse for my angle. So this is a cosine problem. So it's going to be the cosine of, let me give myself some more room, the cosine of that angle, I know this feels really weird, equals adjacent over hypotenuse. Well, if y is up high, all I got to do is multiply. So it's going to be 15 times the cosine of, that angle. That is what y is going to equal. That's what I'm going to type into the calculator exactly like you see it. Practice doing it. I'm going to type 15 cosine, and I don't know if I actually need parentheses. I'm going to try it without parentheses. Yeah, I'm going to get brave. Inverse tangent 12 over 15. And is that the right number? I'm going to put parentheses on it to confirm. And it is. All right. So it actually seemed to work. Let me check again. 11.713. If I go back, I forgot what the number was now. Oh, man. Yeah, the Casio understands it. So just so you can see what I've typed in, let's go to the Casio screen for a second. Just so you can see it, look at what I typed in, exactly like I wrote it. Some calculators probably need to have parentheses around the inverse tangent, but mine worked okay without it. All right, and so if I'm rounding to the nearest thousandths, then y would equal 11.713. So there's my x and there's my y. That's a hard question. The quiz has hard questions. Get ready, buckle up, moving on. Here's another one, hard again. I got right angles, I got 3 triangles. I got to figure out what to do, how to do it. If I look at the triangle that has y and z on it, this blue triangle, I'm going to draw it down here just so I have it because I know I need to work on it. I have y and z, but that I have nothing else. So that's not where we're starting. If I look at the green triangle, is this going to be a triangle I could work on? It looks like it. The green triangle has an X and a 27, and this is 12. Oh, yeah. So I can definitely work on the green triangle. I have a side and an angle. I can get X right away. I'm going to do that. X is going to equal 90 minus 27, so X is going to equal 63. All right, so I got X right away. And then I need to solve for pieces that will help me on blue. There's a couple of things I need to do. First off, if that's 27, I actually do have something on blue. I just realized. If this is 27, then this is also going to be 63 because these two angles have to add up to that 90. So that's helpful to know. So that is a 63. So we do have the 63 up here, but that's still not enough. We need one of the sides. Well, look at the triangles. Look at green and blue. Don't green and blue both share this side? This side is on green and blue. So if I could get that side length, could I then use trig and the angle to get the other sides? Yes. You need one angle and one side to make it happen. So there's already x, y, z. I'm going to call this w. Actually, I'll need it over there. I'll call it w. We can solve for w over here. So what are we going to do? We're going to do some trig. Getting triggy with it. We have the 27-degree angle. This is adjacent hypotenuse for my 27. So it's going to be the cosine of theta equals adjacent over hypotenuse. So I'm going to, if w is up high, all you got to do is multiply. Get it right your first try. So this side is 12 cosine 27. Now we have that side length. Notice I didn't type it in. I didn't round it. We're going to get tricky with it 2 times. I'm going to do opposite adjacent first. Here, I'll change the color on that. We're going to do opposite adjacent, which is tangent. So let's do the tangent of 63 equals opposite over adjacent. And if y is up high, all you got to do is multiply. Well, what does that look like? That's going to be 12 cosine 27 times tan 63. There's more than one way to type this in, but make sure you're able to type this in. So I multiplied the 12 cosine 27 over, so 12 cosine 27, and I'm going to do times the tangent of 63. Different calculators process things different ways. You need to get an answer of 20.984. If you got anything else, you did something wrong, you might have to correct it with some parentheses or something like that. So make sure you're trying to get that answer and you know how to type it in. Okay, let's go and solve for z now. When we're talking about z, we're still using this angle, and we're still using the adjacent leg, because that's the side we know. Now we are going to do hypotenuse. So that is going to be cosine of 63 equals adjacent 12 cosine 27 over hypotenuse, which is z. If z is down low, z and the other side switch places, you know. So 12 cosine 27 over the cosine of 63. And that's what it looks like. I'm going to type it in exactly like I wrote it. Please practice typing this in. I'm going to round to the nearest thousandths again. So that is going to be 12 cosine 27 over the cosine of 63. And that is 23.551. Woo! So that is the question. We're done. We got X, we got Y, we got Z. Feeling real good about all that. Looking real good. That's a hard question. It's about keeping things nice and clean and only rounding at the end. It's understanding it's okay to write things like that even though it feels bad. All right. Now we got some word problems. A woman is standing on the ground at a point 78 feet from the base of a building. So on the ground, we got a building, and we are 78 feet from the base. from the ground, so we're talking about an angle from the ground, the angle of elevation to the top of the building is 57 degrees. So this is the situation to the nearest foot. How high is the building? Height, altitude, vertical distance, they're going to all be that vertical line. So now it's time to get tricky. This is a tangent situation. We have the tangent of 57 equals opposite over adjacent. If x is up high, all you got to do is multiply. And then I'm going to type that in, 78 times the tangent of 57. Round to this one says to the nearest foot, so we pay attention. That's 120 when you round to the nearest foot, 120 feet. And I know you science people especially, but a lot of people are mad. I don't write units. I know. It's whatever. I'm sorry. I'm not really that sorry. No, I'm sorry. I don't know. Let's go. A submarine starts on the surface. I should have said like of the ocean. So a submarine's on the surface of the ocean. Its dive is at a 13-degree angle of depression with the surface. So we got ocean water. We got this submarine. I don't know what a submarine looks like, but it's a ship, and it's on the surface, and it's doing a dive. And it says it makes an angle of depression with the surface of 13 degrees. The submarine travels a distance of 890 meters. That's the actual distance. It did not say horizontal distance. It did not say a depth of 890. It says the submarine travels a distance of 890. That's the path of the actual submarine. As the submarine's moving, that's the path it's taking. So this would be a horizontal distance. That's not what they said. This would be a vertical distance or like a depth. Or how far down did it go? But it said the actual distance of the submarine is 890. All right. What is the desired, before reaching the desired depth? So once it does that, we're at desired depth. What is the desired depth? I might call that x. Depth would be the vertical distance. And what is the horizontal distance? I'm going to call that y. So two trigs, we can do this. Let's start with x. That would be opposite over hypotenuse. So the sine of 13 equals opposite over hypotenuse. So x is up high. All we got to do is multiply. So 890 times the sine of 13. No rounding instructions. I'm going to go to the nearest thousandths again. So that'd be 200.206. And that would be... Part A would be 200.206. And then the second situation is the horizontal distance traveled. That is adjacent over hypotenuse. So that is the cosine of 13 equals y over 890. So if y is up high, all you got to do is multiply. Get it right your first try. And so when I type that in, I get 890 cosine 13. 890 cosine 13, and that is 867.189. So this one is 867.189 if I go to the nearest thousandths. All right. Nailed it. Understanding what the words mean. Critical. Critical. An observer on a cliff 1,000, that DM? I don't know. Above sea level, sights two ships due east. The angles of depression are this and this. Oh, decimeter? Okay. Find to the nearest decimeter the distance between the two ships. So I got a cliff, and we've talked about this in class. So like there's these two ships out here, and there's two ways to think about this. It mentions angles of depression. So a lot of people would actually draw it like this, where you go boop, boop, boop. There's an angle of depression, and then you draw your second triangle, boop, boop, boop. I think that gets really messy. I don't like drawing it like that. I'm not going to draw it like that. So what I'm going to do instead is draw angles of elevation from the ship's perspective. And I think that's a lot easier to conceptualize here. So this is the situation. Now, one thing I've talked about, like if I'm standing here and I'm looking at things, and let's say I got a friend that's, I don't know, I spot something that is like here, and I spot something that's like here. So think about that horizontal line coming out of my eyes, right? As I'm turning my eyes, right? Like right now it's 0 degrees, 1, 2, 3, 10, 20, 30, 40, I don't know. As I look at this object, and then I look at this object, what has to happen to look at the closer object? I got to look down even more. The farther object, I don't have to look down as much. If it was something right at my feet, I got to look way down. Like, look down. You're turning your head almost 90 degrees. Versus if you're looking at something far away, you don't have to turn your head very much. So the ship that is closer is the bigger angle of depression. And remember that angle of depression for one object, so if this is my depression, the angle of elevation is going to be the same number. So I like to think of it as angle of elevation. So the closer one is the one that has the bigger number because I have to have a bigger angle of depression. And the farther one has the smaller number, and the cliff is 1,000. All right, so I got my situation here. Now, I'm going to draw this as two separate triangles just so we can see it. We have this first triangle that is 1,000, and it's 47 degrees, and I need this number. So that's going to be the tangent of 47 equals opposite over adjacent. If x is down low, x and the other side switch places, And so that's the x value. Then the second triangle is a little farther out, right? I'll kind of highlight it so you know what we're talking about. I'm going all the way. I'm talking about this green right triangle. Green right triangle is farther away, and I have 32-degree angle of depression. Well, it is angle of depression, but it's elevation for the ship. And we're still 1,000, that thing, decimeters. I'm going to call that y. So I'm calling the entire distance here y, and the shorter distance here is x. Okay, so that is going to be tangent again. Tangent of 32 this time is 1,000 over y. When y is down low, y and the other side switch places, We're getting tricky with it. Okay, so we got all that work. Well, now what do we need to do? We need to find the actual distance between the ships. So let's just make up some numbers. Let's say this was 600 and this was 100. Wouldn't this have to be 500? 600 minus 100 would give me that distance. Okay, that's the process we're doing. It's just it's not 600 and 100, it's these numbers. Well, the bigger number is y. So we're going to do y minus x. That is 1,000 over tan 32 minus 1,000 over tan 47. Practice typing this in. 1,000 over tan 32 minus 1,000 over tan 47. And it says to the nearest decimeter, so that's like a whole number. So I got 667.819, which rounds to 668 based off what they're asking me to do. A lot of work, not easy. This is a pretty common situation. We did one like this in class, El Capitan, as Alex was climbing the mountain. It's just like that question. All right, here we have Aparna is 35 feet away from a tree. So we got our friend Aparna chilling. Boop, boop, smiling. And there's a tree. And let's see, we got this tree. And the tree has some green. Okay, there's my beautiful tree. It says from her eye level, the angle of elevation to the top of the tree. And it's kind of hard to draw. It'd really be like right here, but I don't want to work in the middle of the tree. So I'm just going to kind of, something like this. The angle of elevation to the top of the tree is 5 degrees. And the angle of depression to the bottom of the tree, I'm going to kind of write it over here. I don't know, my picture's not great, but we're going from the top of the tree to the bottom of the tree is 7 degrees. So she's looking straight ahead. right? As she looks straight ahead, right? She's looking straight ahead. As she turns her head up 5 degrees, she can see the top. Well, going back to looking straight ahead, as she turns her head down 7 degrees, she can see the bottom. So that's the scenario, and it says she's 35 feet away. So we got 2 triangles. I'm going to call this X, and I'm going to work on that triangle first. Got it. So this is 5 and 35, and we're looking for X. That's going to be a tangent. Tangent of 5 equals opposite over adjacent. If X is up high, all you got to do is multiply. So 35 tan, oh, why am I, we're not typing that in. Let's leave that alone. All right, and then I'm going to call this part Y. That's not a different enough color. What do we want? I'll make, ooh, that color looks fun. Make that Y. All right, so then this triangle looks a lot like the first one. But it has a 7-degree angle. It's still 35, and this is Y. So this is tangent again. The tangent of 7 equals opposite over adjacent. If Y is up high, all you got to do is multiply. Get it right your first try. 35 times the tangent. Oh, why did I type it in? I don't care. Not typing it in. The height of the tree would be the combination of X plus Y. So that would be 35 tan 5 plus 35 tan 7. Now I can type it all in. So 35 tan 5 plus 35 tan 7. There's no rounding instructions, so I'm going to go to the nearest thousandths. 7.35. Ooh. Practice rounding this one. People mess this up. This will be the most common thing we mess up rounding. Make sure that you can do that. All right. Oh, yeah, this worksheet is awesome. We still got 3 more to go. Okay, so we're working. We got Ryan, Shreya, and a plane. So we got 3 things for a triangle. Form a triangle. All right, the plane is between Ryan and Shreya. So let's say we have Ryan, we got Shreya, and we got a plane. Okay. Ryan and Shreya are standing on even ground. Even ground, like it. The angle of elevation from Shreya to the plane is 40 degrees. The current altitude of the plane is 12,500 feet. What is the horizontal distance from Shreya to the plane? So, wait. Okay, so this is my Shreya. This is my Ryan, based off my picture. I need to make sure I got that. The angle of elevation from Shreya to the plane is 40 degrees. So I put the 40 degrees on Shreya. That's an altitude. Altitude is always a vertical number. So 12,500 is my altitude. And I want the horizontal distance from Shreya to the plane. Well, if that's Shreya, call this X. That's my horizontal distance. This is my actual distance. That's not what it said. It said horizontal distance. Okay, so I'm going to work on just that triangle. I'm going to do it up here because I want room. So let's make sure we got the numbers correct. We got 12,500. We have 40 degrees, and we're looking for this number, the horizontal distance. So that would be the tangent of 40 equals opposite over adjacent. If X is down low, X in the other side, switch places, you know. All right, so there's my horizontal distance. And that's what they're asking for. So I'm going to type that in, 12,500 over the tangent of 40. And I get 14,896, and I'm going to round to the nearest thousandths. Oh, another fun one. Make sure you practice this. It's 920. Okay, I like it. if Ryan, so now we're talking about Ryan, is 2,000 feet from Shreya, what is his angle of elevation to the plane? So, to get his angle of elevation, I need two sides of this triangle. So I'm going to draw that triangle down here. What do we have? We want this angle. We have this side. We need one of those two sides. Well, if he's 2,000 feet from Shreya, we can get it. We know that the bottom, we know the bottom, it's 14,000 something, right? Wait, where did I mess up? That can't be. Oh, it's 20,000 feet. Okay, there we go. That makes more sense. Do not do 2,000 minus the decimal. We don't use rounded numbers to find new numbers. It's going to be 20,000. I keep saying 2,000. 20,000 minus, and you just leave it alone. You write it exactly like that. Don't type it in that's how long it is. Now we know that number is like what? We know it's this number, but we don't want to use a rounded number. And now we're going to do trig down here. So this would be the tangent of x equals opposite over adjacent. So how do we fix this? Well, how do we get rid of this tangent? We're going to do inverse tangent. So it's going to be inverse tangent of all of this. And I'm going to type it in my calculator exactly like I wrote it. I'll show you in a second. Inverse tangent, make the fraction, 12,500 over 20,000. Get all those zeros. 1, 2, 3, 4, 5 zeros. Wait, 1, 2, 4 zeros. 1, 2, 4 zeros. Okay. 20. I'm so confused. 3, 4 zeros. Okay. Minus 12,500. Another fraction over the tangent of 40. So take a look. Take a look. That's what I did. Woo! If you have different calculators, figure out a way. You're going to have to use parentheses correctly to get this in. The Casios are nice, but you need to get to that final answer or you're not correct. So final answer here is, what is his angle of elevation? I called it x. I'll call it, I called it x. I'll keep it x. X equals, and they did not tell us how to round, so I'm going to go to the nearest thousandths, 67.792. If you rounded and used rounded numbers to get there, I mean, there's a chance you're okay, but there's also a chance you're not okay. So it's hard to know when. I'm not going to test it out right now. I could test it out with the rounded numbers and see if I get the exact same thing, but don't risk it. You don't know when it's going to be okay and when it's not. All right, the angle of depression, last one. Oh, man. The angle of depression from the top of a building to a pond is 60 degrees. So a depression triangle. So the angle depression is 60 degrees. If the building is 25 feet tall, so I understand that like this is the height of the building, but the building is physically over here. But if it's 25 feet tall, then it's 25 feet tall. It doesn't matter where I put that number. It's 25 feet the whole time. What is the distance from the pond to the top of the building? So here's the pond down here. What is the distance from the pond to the top of the building? That's this length. That's what we're looking for. So I'm going to call that x. Guys, I don't know how strict I'm going to be with this, but if you see a 60-degree angle, you don't need trig. You don't need sine, cosine, or tangent. I really don't even want to see it on your paper. I need you to know how 30, 60, 90s work. divide by 2. We've done this before. No. This is the long leg. Sorry, this long leg. The long leg equals the short leg times root 3. So 25 equals the short leg root 3. So we need to divide by root 3. So this side will be 25 root 3 over 3. And then multiply that by 2. And this would be 50 root 3 over 3. If there are rounding instructions, you do need to type that in. That would be 50 root 3. Make sure you know how to do this over 3. The decimal version is 28.868. So if it tells you to round, make sure you round. Otherwise, you can leave it exact like this. If you did it with trigonometry, you'd get the same answer, right? If you had said the sine of 60 equals 25 over x, you would have got the same thing. If you do 25 over the sine of 60, just to kind of show you here, like it is the same work, but I don't want to see it that way, guys. But yes, it is the same thing. It's the same answer. If it's 30, 60, or 45, I really want you doing it using the rules we learned last quiz. Okay. Love it. Man, I want some more. Should I make more questions? I don't know. That was a lot of fun. All right, guys. This is a high effort weekend. I don't know if it's weekend for you right now, but this is a high effort situation. If you come in low effort on this quiz, this is going to be a tough quiz for you. As you saw, these are hard questions that take a lot of thought, and you have to really understand what you're reading. I know you can do this. You're some of the best students that exist. I know you're going to put in the effort. I look forward to seeing how we do on this quiz. Love you guys.